Pretty much everything you see here, I have got off eBay for pennies on the dollar, except for this one. A good friend of mine gave it to me. And, but again, every one of these things are different and for different applications. This one, believe it or not, came off an RF application for a military radio system. This is a high voltage bushing for a transformer. This is for a vacuum application, but it's reverse. So you have the bushing on the vacuum side, and you have this threaded portion on the atmospheric side for whatever unique application this thing was for. I don't know, but it is vacuum capable, and there would be no issue with this holding a vacuum. But the problem is you're going to have to either use some sort of modification to make this side the mating side. So again, you could machine something, you could put some type of O-ring on here, and but you would have to make a mating surface compatible with the 2.75-inch conflat system if you were going to use that to work with this, because that's the conflat side, which is the side you're not going to use. This is the side that's going to host the grid stock. And so you're going to have to come up with some sort of, maybe you could put a washer in here with an O-ring on it, and then put another O-ring on the top. But this would not be very difficult to modify to make for a fusor application. Not at all. Especially if you had a lathe and a standard cutoff saw. I do not see any issue at all modifying this one. This one would be extraordinarily simple. Even though it's for an RF application, you can see it's got the soldered on top post. I would be willing to bet that this is completely vacuum tight. There would be no leakage whatsoever. And if there was, it would be a very easy fix with something like JB Weld or some sort of epoxy just put around the leading edge. The bottom here, you just clean it up. You could take this old metallic ring off. That would be pretty easy. Then you would take something like this aluminum bar stock. You cut off probably about a 3/8 inch or maybe even a 1/2 inch thick slice of this, kind of similar to this here, just not obviously as big in diameter. And you would replicate this flange, but with a central opening, not to host this bushing, but to host this one. And you can see the feed through the stock here would be very simple. Even though this is brass, actually, if you look closely, this one actually is threaded too. So you could even put a coupling on here pretty easy. But again, you could drill this out, put a grid stock on here at whatever length that you need, and then mount it into your new mounting flange. And really all you would need to mount this thing on to make it perfectly airtight and suitable for fusion, neutron production, is all you need is JB Weld. Don't let anybody tell you different. There's going to be a whole bunch of people, oh, it's going to outgas, oh, it's going to do this, oh, it's going to do that. BS. JB Weld works perfectly fine as long as it is on the outside of the chamber. If you put JB Weld anywhere on the inside of the vacuum chamber, it is going to be exposed to plasma, and it's going to outgas and cause a whole host of problems. Do not put epoxy inside your fusor chamber. The epoxy needs to be on the outside, and it'll work perfectly fine. There'll be no problems whatsoever. I've tested it countless times. I've had millions of neutrons per second without any issue of outgassing, as long as the epoxy is on the outside. So anyway, that would be an easy high voltage feed through to make. Now, let's say you don't have anything like these. Let's say you've got a regular high voltage bushing for a transformer like this one that is completely hollow. You're like, oh my gosh, what can I do? Can I pour a whole bunch of epoxy in here and seal it up? Or can I come up with some sort of hybrid ceramic that I can throw in here and seal it up and maybe put a stainless steel core through it. Well, yes and no. You want to stay away from filling these things up with epoxy, and any sort of non-baked ceramic that you're going to put in here is just going to outgas, like, you may as well just put a kitchen sponge. It's just not going to work. So here is the fix for something like this, which, by the way, these are really cheap. You can get these on eBay really cheap, maybe $5 or $10 a piece. The most expensive part's going to be shipping. But all you need to do, okay, I'm going to walk away from the camera real quick and show you something. Okay, I am back. All you need is regular aluminum bar stock like this, okay? Now this is a little bit too big in diameter, but you can get aluminum bar stock that is the right diameter, or you can machine this in a lathe. So it fits really, really close down the diameter of the ceramic feed-through. And all you do is, again, going back to the JB Weld, you just epoxy the upper portion, so the area that's going to be up in here, to make it sealed. So you would feed it to the bottom, okay, and push it through. You've already kind of put all your epoxy on the inside here, made it nice and even, and put some on the outside diameter of your aluminum rod stock that is pre-cut to size, and you just slide it in, let it dry, and you have an absolutely airtight, solid, temperature-resistant, fusion-capable feed-through. That is all you need to do. And what's nice about the aluminum is, before you insert this thing for permanent installation, is you just drill a hole through the center. You could tap it, so you can have a pre-drilled or tapped, excuse me, piece of stainless steel TIG rod, and screw it in place, and you can use that as your stock for your fusion grid, and it'll be good to go. Absolutely good to go. And obviously this long piece here, you just cut it off. Just get yourself a ceramic saw and cut that off. You don't need it, because what you're going to be doing is you're going to be going back to this again. You're going to make a flange, like I said before, similar to this, and you're just going to sink that right in there in the middle. And again, you're going to use JB Weld once again to hold it in place, and it's all good to go. Fusion ready. Don't let anybody tell you different. It will absolutely work. I keep saying over and over and over again, the Fusor is a very forgivable design, as long as you pay attention to certain specifics. You do not need to waste a whole bunch of time on the minutia. Basically, what I'm telling you will work perfectly fine. So, with that aside, let's move on to actually making the high voltage feed through that I am going to use, including the grid, and finish off this video so we can proceed on to the power supply video and possibly getting first light. So let's go ahead and move to the lathe, and I'm going to show you basically what I got to do in order to bore out this small piece of stainless steel TIG rod. So one of the tricks to centering your shaft drilling when dealing with something this small, I typically use a live center on the lathe. So you just need to make a small little indentation. You definitely want to start off slow, just so you don't get it misaligned. There you go. And give it a little bit of a snug fit till you can tell that dimple gets made in there. And that's about it. And you've got your your centering mark for the drill. Drilling out this stainless steel TIG rod is a real delicate procedure. I can't imagine doing something like this with a drill, like a hand drill. You've got to use a lathe and go really slow at it. And obviously you've got to keep the drill bit well lubricated with cutting fluid. And you just got to go real slow, little bit at a time. There's no rush at all on this. If you don't have a lathe, this is kind of one of those kind of necessary, or pretty close to it, items you're going to need if you want to go full steam into any sort of fusor work. Because you got to make so many small, tiny parts. So I got to do both sides of this coupler. So one side will fit the shaft coming out of the feed-through, and then the other side I have to drill out with an even smaller diameter to put the grid into, which I'll kind of show you here in a minute. Okay, so I got about 1/2 of this grid stock done, and the tolerance is just good enough where I can have a very tight slip fit. You're not going to need much more than that. So I'm not going to press it on all the way at this point, but it is probably right about there. I'm going to make a mark to see exactly how deep this goes. Now what I need to do is determine where I want my grid in relation to the conflat cross. So I want my grid to be centered within the cross, which means I'm going to have to cut this coupling down to the proper size where the grid stock will be able to center itself properly within the conflat cross. Okay, so you can see I've just kind of loosely placed the feed-through on top so I can kind of center the grid stock to where it should be. Now this 10mm wrench is going to give me a good idea of my fusion grid and where it's going to land. So I got this blue tape here. I kind of eyeballed it earlier, but if you cut it right there and then I bore it out, I should be able to get my fusion grid lined almost perfectly with the center of the conflat cross. It's not rocket science. You can be off a little bit here and there, but the thing is that you want to keep away from doing is obviously to have your grid down here or too far up in this area. You definitely want to keep it in the central region. Okay, the coupler is now complete. There's really no reason to go into a lot of the specifics on measurements because the feed-through that you're probably going to use is going to be totally different. This is just a rule of thumb kind of showing you what I'm doing. The most important part is the grid itself. And what I'm using is 1/32 inch stainless steel TIG rod. I'm using this 5/32 inch diameter socket extension as a mandrel. I'm wrapping it around it a couple of times and then using these pliers, I'm just kind of bending it to give it the pigtails where I can loop it around and stuff the pigtails directly into one side of the coupler. So it's really as simple as that. It's a friction fit. It's pretty tight. It's not going to go anywhere. The only thing I would recommend for you to do, it's not necessary, but if you're having a problem and it's kind of loose, is to, if you've got access to a capacitive discharge spot welder, you can spot weld the top of these loops together, and that will kind of hold them in place. So I've got one that I made here. There we go. Where I kind of spot welded it too much. I'm not going to use this grid, by the way, but this was kind of gives you the idea of what you might be able to do to keep it from opening up, because these things do tend to deform a little bit under the heat conditions within the fusor. All right, and there you have it. It's all press fit in. That's not going to be coming out. It's nice and tight, and it's pretty much symmetrical. It's a little bit, but the thing is, again, I said before, this is not rocket science. There's a lot of forgiveness in building these systems. So don't overcomplicate this. That's actually one, you've probably heard me say this multiple times so far already. Don't overcomplicate this. I've seen so many people get bogged down in the minutia, and they will spend, I'm not kidding, years, literally years, focusing on tiny little details like this, and they end up never finishing their fusor. Just put it together. I'm not saying do a hack job. I'm not saying, you know, cut corners, but you do have to make allowances. And the fusor, by design, is a very allowance-friendly system. So there you have it. And this is more than capable of making neutrons. All right, so that takes care of the feed-through portion of this video. And there's no point in bolting this whole thing together. It's just going to be a waste of time. But I think we all know how to put these together. So this feed-through is going to use this O-ring, and it is going to bolt in right there. And then on the next video, we're going to work on the power supply, and we're going to talk briefly on the gas handling system. But I believe once we get that power supply squared away on the next video, I think we're going to have first light. Now, before I conclude this video, there's one thing that's extremely important to point out. Obviously, I just put this whole thing together with my bare hands. I've done a bunch of machining. I have not cleaned anything up. There is cutting oil on this. There's fingerprint oil. There's everything under the sun. So get some acetone, clean off all of your fusor grid parts, and use gloved hands before putting this whole thing together. And you're going to save yourself a whole bunch of headache by doing so. All right, there you have it. One complete high voltage feed through with the grid intact.